When the first plows turned over the prairie sod, the early farmers unearthed a rich, dark soil. Have you ever wondered why? I have a hunch that it's related to the mosaic of plants that paints our beautiful Minnesota landscape. In ecology, we call this the plant biodiversity and measure it by counting the unique number of plant species. Now, to understand something in science, we need to do an experiment. A crazy kind of experiment where we seeded over 150 different prairies, ranging from bare ground plots, never planted, one plant species on its own, 2, 4, 8, and 16 different prairie plants. This experiment allowed me to ask my dissertation question: is it the plant biodiversity of the prairie that makes its soil so fertile? The answer was yes. We discovered that compared to any one plant grown on its own, in what you may have heard described as a monoculture, plots that were seeded with a diversity of prairie plants have built soil fertility. In our most diverse prairie, we measured an increase of 13 tons per hectare of carbon taken from the atmosphere, put back into the earth. This is shown in the rich, dark color that is characteristic of prairie soil. Compared to the monocultures, there was a 300% increase in the amount of calcium, magnesium, and potassium. All nutrients that our food crops need to grow, that our wildlife needs to grow, that our children need to grow into healthy adults. The amazing thing is that these changes from the left to the right occurred on a human-relevant timescale. 25 years to go from a sandbox to a fertile prairie. Across the world, we've degraded our ecosystems and our soils. And there's a lot of doom and gloom out there. But what if we had an option? An option to restore and rebuild our ecosystems, to feed more mouths and protect our wild species. The restoration of plant biodiversity may be the key to replenish our degraded lands, to turn sandy, infertile soil into something our farmers can use to bring us nutritious food. A healthy land supporting a healthy people. This experiment I've described at the Cedar Creek Ecosystem Science Reserve is the longest-running biodiversity experiment of its kind in the world. We've simply never had an experiment running long enough to demonstrate these unprecedented effects. We are now beginning to determine that prairie soil may not be fertile because the plants were diverse, but that the soil may be fertile because they are diverse. Thank you.